All right, let's solve this triangle. So by solving this, we're going to find all the unknown sides and all the unknown angles. So we complete everything in this triangle. So one thing to note on this triangle is we don't know if we have a right angle or not. None of these are designated as right angles. We are given one angle is going to be 30 degrees, but no guarantee what the other two are. So being that we know our 30 degrees, but we don't know the opposite side length, we can't really use law of sines. So we're really limited here. We have to use the law of cosines. So I've given the different varieties of this. One, I like using these top versions if we're solving for a side length. I like using these bottom versions if we're solving for one of the angles. The bottom versions are just rearrangements of the top versions, so don't get thrown off by that. So based on the information we know right now, we know this one angle. So let's use that angle. It's beta, so let's use this middle version right here and see if we can fill in all the information we need to find b. So b squared is going to equal a squared, which is 10, plus c squared, 12, minus 2 times a times c times cosine of beta. All right, so beta, 30 degrees, everything gets filled in. Now we have a bunch of numbers over on the right-hand side and this cosine of 30 degrees. We can evaluate that in just a second as well. But really, let's just do a little bit of simplifying down and solving this. So we can say 10 squared is 100. 12 squared is 144. And then minus, let me see, 2 times 10 is 20, times 12, it's going to be 240. Times cosine of 30 degrees. And then as we get going on this, we can do a little bit of work and combine all this together, maybe simplify down by filling in for cosine of 30 degrees. But in all honesty, I'm probably going to put this in my calculator in just a second anyway. I want to get b on one side all by itself. I don't think this will work out to be a nice perfect square on the right-hand side. So I'm going to apply a square root to both sides, thus getting rid of this square on my b. So here we get b on this side. I'll go ahead and put all of this in my calculator from the right-hand side, making sure that I'm in degree mode for my calculator to get this cosine of 30 degrees in. And then from there, let me see the square root of all that. I got this to be about 6.01. So I'll label it up in my triangle. All right, next, I guess we still have two unknown angles. So as we have these unknown angles, we can go back to the law of cosines, use one of these bottom versions, and that's not a bad idea. In all honesty, is use one of these versions of law of cosines to try to solve for either gamma or for alpha. The other option we have here is now that we have an opposite pair, we have this angle beta and side length b. Our other option here is we could use law of sines. So let's use the law of sines in this case. I'm going to go ahead and say, well, I have sine of 30 degrees over the opposite side, 6.01. And that has to equal, now we have options. We can either solve for alpha or for gamma next. Let's solve for alpha. So I'm going to say sine of alpha over the opposite side length, 10. My next steps are going to be, I want to isolate the sine of alpha. So I'm going to multiply both sides by 10. Now that's going to put sine of alpha on one side all by itself. On the other side, we still have kind of this mess going on. Not a mess, but you get what I'm saying. All right, so we have to get alpha out from inside of this sine, and that's a function. So what we're going to do is utilize a sine inverse, the arc sine, to counteract that sine function. And what's going to happen on the right-hand side, as I've written it, is we're going to be left with just alpha. So alpha is going to be on this side all by itself. And then on the left-hand side, this is another, put it in your calculator, see what comes out. Sine inverse, that's second, then sine, 10 times sine of 30 degrees, close some parentheses, divided by 6.01, maybe close some more parentheses, and press enter and see, let me see, that's going to be 56.30 degrees. Again, make sure you're in degree mode to do this calculation. So what is that, 56.30 .30 degrees, going to go down in this corner. Now you may want to double check whenever we have to utilize a sine inverse function. You want to double check that angle that's given to you or that comes out of the calculator, and just make sure you couldn't have a second one by basically using this as a reference angle into the second quadrant. That's not going to be the case in this one because that's larger than the initial angle that's given to us. So we don't have to really worry about that. All right, last thing we want to find is that remaining angle gamma. So to get that angle, I think the easiest way to do this is remember that you always have to add up, all your angles have to add up to 180 degrees in a triangle. So we can say 180 degrees, start with that and subtract off the two that we already know. Pretty easy calculation. Get the calculator out to help you if you need. And then let me see, we have 180 minus 30 minus 56.3. I got 93.7 degrees for that remaining angle. Now, one thing to kind of double check when you get done with this, the largest angle, in our case, 93.7, is across from the largest side length. Medium angle, 56.3, across from the medium side length, and smallest angle across from the smallest side length. All right, hope this helps out as you're getting used to the law of cosines. Good luck.